This video presents one of the experiments that we ran in order to evaluate the node manager. We deployed the system in Azure using Kubernetes. In particular, we used two machines as worker nodes, equipped with 6 cores and 1 GPU each. We installed two applications, GoogleNet and Skyline Extractor from the Snow use case. We created two synthetic workloads with a step-like shape. As we will see, the experiment starts with the moderate traffic for both the applications. Then a peak of request for GoogleNet starts, and as soon as it finishes, a peak for Skyline Extractor comes in. For the control, dispatcher was configured to use a longest queue heuristic for GPUs, while a fair round-robin strategy for CPUs. In the workers, the node manager is equipped with PID controllers to fine-grain control the CPU allocation of each application. For the experiment, we present 4 charts. In all of them, GoogleNet data are shown in red, while Skyline extractors in green. From top to bottom, the first chart shows the average response time at each second, while the horizontal lines depict the SLAs. The second chart shows the workload as number of incoming requests per second. Herein, we will see the two step-like shaped synthetic workloads coming in. The third chart shows the number of requests executed by the GPUs per application. We will see how the dispatcher favors the applications with more requests in the queue. Finally, last chart shows the core allocation per application in a single worker node. Note that the minimum core allocation was set to 1 core. The experiment is started. At the beginning, the workload is moderate for both the applications. The response time is kept below the SLAs with a close to minimum core allocation. Since the workload of the two applications is similar, the queue length is also similar, and therefore the GPUs execute around the same amount of requests per application. As you can see, the peak of requests for GoogleNet started, and the response time suddenly increases. However, the core allocation for GoogleNet is promptly increased, and the dispatcher starts favoring GoogleNet for GPU executions. The slightly violations to the SLA are almost instantaneously corrected, and considering a larger time window, the average response time is kept below the limits. As soon as the peak of GoogleNet ends, the one for Skyline Extractor starts, and similarly our control is very fast in correcting abruptous changes in the response time. Note that the control not only manages workload peaks, but thanks to PID controllers, even unexpected problems that can emerge at runtime are corrected. Finally, at the end of the experiment, the traffic for both the application is again moderate. The core allocation is close to the minimum, and the GPUs are almost equally shared between the two applications.